In the last video, we looked at the basics of status communication. Now we will move on to the digital coded interface mode, known as DCI. The PISA-M provides simple and efficient communication via the digital coded interface. This allows both unidirectional and bidirectional communication through the digital inputs and outputs of a PLC. We will begin with DCI unidirectional mode and then move on to bidirectional mode. In this mode, there is no longer a single status lamp for the whole system. Instead, each channel has its own individual status indicator. In unidirectional mode, these indicators are either gray, which means normal operation, or flashing red, which means that the relevant channel has tripped. We can also see a continuous bit sequence running on the screen. This is shown for visualization purposes, to make the communication principle easier to follow. For the signal coming from the PISA-M, each sequence begins with a 200 millisecond start bit, followed by a 100 millisecond pause, and continues by the channel information, and then repeats continuously. The timing here is 100 millisecond per bit, plus a 100 millisecond pause, with a total sequence length of 1100 millisecond. If a channel trips, the corresponding status indicator starts flashing red, and the bit sequence changes accordingly. So for example, if channel 1 and channel 3 trip, this can be seen both in the channel indicator lamps and in the bit sequence running on the screen. To clear the condition, we press the reset button for 1 second. This button is used for reset only. It cannot switch channels on or off, and the reset always applies to all channels simultaneously. The reset sequence only has to be sent once. After the reset has been triggered, the PISA-M first completes the current output sequence. Immediately after that, the reset is accepted and the updated status is transmitted. Finally, let's look at bidirectional DCI mode. Here, we still see the status of each individual channel on the left side, but now we also have additional control functions for each channel. This means each channel can be controlled individually. For every channel, we can select on, off, or reset. These commands are not sent immediately one by one. Instead, the selected commands are prepared first and then transmitted together when we press send. On the right-hand side of the screen, we can see two separate signal areas. The upper signal represents the PISA-M output, while the lower signal represents the PLC control signal that can be sent to the PISA-M in bidirectional mode. The moving lines visualize the communication signals during operation. We can now see from the status signal output that the current sequence length is still 1100 milliseconds, which means the system is still in unidirectional mode. To switch to bidirectional mode, we need to send a control sequence to the PISA-M. When commands are sent from the PLC to the PISA-M, they are transmitted as a separate control sequence. For example, if we set channel 1 to off, we can select this directly on the monitor. At this point, the command has only been selected. It is not transmitted immediately. The new command sequence is sent only when we press send. This control sequence consists of a start bit, followed by the command information for the individual channels, and ending with a stop bit. Its total duration is 1200 milliseconds. As soon as this command is sent, the system switches to bidirectional mode. From that point onwards, the channel information continues as part of the regular status signal output. We can see this because the duration of one complete sequence on the status signal output now changes to 1050 milliseconds. After send has been pressed, the sequence that is currently running is completed first. Immediately afterwards, from the start of the next sequence, the new transmitted sequence is accepted and displayed. For the signal coming from the PISA-M, each sequence begins with a 150 millisecond start bit, followed by a 100 millisecond pause. Additionally, the status panel now provides more detailed information. In unidirectional mode, the status indicators only showed whether a channel had tripped. In this mode, we can now see the full status of each channel. A green lamp shows that the channel is on, a red lamp shows that it is off, and a flashing red indicator shows that the channel has tripped. Here, we can immediately see that channel 3 has tripped, as its status indicator is flashing red. At the same time, This is visible in the status signal output sequence, where it appears as a 100 millisecond pulse. We can then pre-select a reset for channel 3. At the same time, if we also want channel 1 to be switched on again, we can pre-select that as well. When we then press send, all pre-selected changes are transmitted together in one single sequence to the PISA-M, and it's the same procedure as before. The currently running sequence is first completed. Then for the next sequence start onward, the new transmitted sequence is displayed. For any channel where no new setting has been selected, the previously active setting remains unchanged and is transmitted accordingly. So in bidirectional mode, we can not only monitor the channel states, but also actively send commands back to the PISA-M. In the event of power shortages, or if the unit is switched off and on again, the DCI will reset to unidirectional mode. This concludes our overview of the PISA-M and communication mode digital coded interface. We have seen how the different modes enable status monitoring and instant fault detection. The digital coded interface, DCI, enhances the status monitoring on a channel level and even gives channel control options in the bidirectional mode. Thanks for watching. For more, check out our PULS channel or our website.